The intermediate value theorem. If a function is a polynomial function with only real coefficients, and if for real numbers a and b, the values of f of a and f of b are opposite in sign, then there exists at least one zero between a and b. In this example, we're going to show that this function has one zero between 0 and 1. So the intermediate value theorem can be used to locate an interval that contains a zero. So in this example, we want to know whether or not there is a zero between 0 and 1. So I'm going to use a number line just to illustrate it. So between 0 and 1, we want to know, is there a zero in this region? So to do that, we can either use the plug-in method to evaluate the function, or we can use synthetic division. So I'm going to do both to show you what it looks like. Let's start with the plug-in method first. It means we'll start with our first value here of 0. So we're going to remove all the x's and replace them with a 0 and do the math. So once we do so, it's going to look like so. And notice any number times 0, 0, so all of that cancels out and you're just left with an output of 4. So f of 0 equals 4. Now let's find f of 1. Removing all the x's, replacing them with 1, we're going to do the math. Combine those numbers and that gives us an output of -3. And what we were looking for is that our outputs are opposite in signs. So f of a and f of b, in this case, f of a and b are the 0 and 1. So we plug both in, and the results were that the signs were opposite. So by the intermediate value theorem, that means that this polynomial has at least one zero between 0 and 1. Here's what the graph looks like. And we have 3 zeros there. Notice the zeros, aka x-intercepts. And there is at least one zero that is between 0 and 1.